So today's essential question, guys. Can I find let it record? Can I find all asymptotes and intercepts for rational functions? So last class we graphed, and as part of that graphing we found asymptotes. Okay. We'll keep doing that. We're going to find asymptotes, vertical and horizontal, but we're going to do it without graphing, so all just algebraically. And we'll also find not just x, but y intercepts. The nice thing about x and y intercepts, not much changes at all, and actually not much changes for the horizontal and vertical asymptotes either, if I'm being honest. So I told everybody on Monday, the nice thing about this chapter is there's not a whole lot of new math. It's just the old stuff that we're kind of cranked together. So rational functions, the simple ones we had were like y equals 1 over x, or 1 over x squared. And I told you a rational function is going to be defined as having a, not an exponent, a variable in the denominator, right? How that kind of messes a lot of things up. That's still going to be true. I want to expand it a little bit. I want to call a rational function, so f of x is a function, so like p of x over another function, q of x. And we already saw this in the example problem I did. What can I not have in a denominator? Zero. I can never have a zero, so we'll expand this a little bit and say that q of x cannot equal 0. So whatever function it is, 9 times x to the 5th plus 3x to the 4th, blah, 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 whatever it is, that can never equal 0, because I'll get undefined. That's our working definition. I'm not going to ask you to have p and q of x and all that memorized. Just know that we're not just going to have 1 over x anymore, or negative 3 over x. I can have a function on top and a function on bottom. Yeah?
This all sounds very complicated.
Really, once you start seeing the math, it's not too bad at all. Okay. So vertical asymptotes we talked about already. Vertical asymptotes are at places where when I plug in that x value, I get undefined, right? I get 0 in my denominator, which is undefined. So I give myself a vertical asymptote to say x can't equal that number, right? So a vertical asymptote is give, values that give undefined answers. Alright, so there's one here. I don't have the function of this graph, but I have a vertical asymptote at x equals negative 4, right? That means if I plug in negative 4 for x in that function, right, I would get undefined. There's also a horizontal asymptote, not to worry about that. Let's just deal with vertical for now. Alright? If I have, well, okay, don't worry about it. Good. So, find the vertical asymptotes. It doesn't say by graphing or anything like that. I just want to find vertical asymptotes. So, it doesn't say this, but you can read into it. Find values that when you plug them in, give you 0 on the bottom. Now, we could sit here all day and just guess numbers and keep plugging them in for x and see if back here on the bottom, x squared minus 5x plus 6, plug in 7, plug in 9, plug in 3 million. Plug in all these numbers and see if I get 0, right? Well, that will take an infinite amount of time. So rather than spending the rest of our lives trying to solve one problem, I'm going to give you an easy way. I want to get zeros here, so I'm going to factor that, guys. So that, there you go. Always start by factoring. So factor. You can't factor negative 2, so we're not going to worry about that. So this becomes negative 2 over. Use just AC method here. I need the factors of 6. Yeah, 6 and 1 is definitely what you're going to do. Which one's positive, negative? Good, yeah. So I'm going to have x minus 6, and x plus 1. X minus, well, that's not going to work, right? Look at that. I'll have a negative 6, and I'll have my negative 5. Good. 3 and 2. You guys think factoring is still important? So x and 3, x and 2. Which one's plus? Which one's minus? They're both minus. Don't I need a negative 5x, Grant?
Yeah.
So that'll give me my positive 6. It'll give me my x squared. I'll have a negative 3x and a negative 2x, which add up to negative 5x, right? Good. So that helps me a little bit. Now I can see a little clearer what numbers, if I plug them in, will get me zeros in the bottom. You're going to do this actually exactly like you solved. If I gave you in this equation said solve for x, check your answers and everything like that, you would factor. And what would you do with each of these factors? Well, set them equal to 0. So I've got x minus 3 equals 0. So x equals negative 3. I'll get x minus 2 equals 0. So x equals 3. Sorry, positive 3. I was thinking 3 over here. 2. My bad, it's positive. This is a mistake, right? So think about that. If I plugged in 3 for x, I'd have 3 minus 3, which is 0. And I'd have 3 minus 2, which is 1. And 0 times 1 is 0. So I'd have a 0 on the bottom. If I plug in 2, I'd have 2 minus 3, which is negative 1. And 2 minus 2, which is 0. And negative 1 times 0 is still 0. Either way, for each of those answers, I get a 0 at the bottom and an undefined answer. So I have vertical asymptotes where
3 and 2.
X equals 3, X equals 2. So now all of a sudden, we got to be comfortable for one day, not just one vertical asymptote, but 2. So
That's French. French.
cool.
Zero is factor the numerator.
The numerator, so Colton asked, would you have to factor the numerator? We will have to factor it later on. Guys, you don't have to factor the numerator when you're finding vertical asymptotes. Because can I have 0 in the numerator? Yeah. Yeah. So I'm only worried about the denominator, guys, when I'm talking about vertical asymptotes. Anything can happen up top in the numerator. You good?
Yeah.
I'm done. Anything can happen in the numerator with regards to vertical asymptotes.
I'm just smelling it.
But, yes. So those are my vertical asymptotes, guys. This would notice what I boxed there. My symbol for vertical asymptotes, and then 2 lines. That's not just 3 and 2. It's x equals 3 and x equals 2. Remember, my asymptotes are always lines. So you need to give me it as a line with an equation, right? I talk about lines with equations. I'm going to erase this just so I've got a little more room. So that's vertical asymptotes. You're going to factor the denominator, and then solve for x, right? And yes, that'd be I'm okay with that. Good. Horizontal asymptotes are different, and they're actually, I think, easier to find, easier to calculate. So if a vertical asymptote tells me where I get undefined answers, a horizontal asymptote will tell me about end behavior. All right.
Are these always going to be x doesn't equal something and then y? Oh, wait. I'm sorry, go ahead.
Yeah. You're thinking about domain and range.
Yeah.
Yeah. Hold on. We'll get to that. Good. So horizontal asymptotes will tell me about end behavior. So on this guy, I've got one horizontal asymptote, right? Where is he?
0.
He's at 0. Okay. So if you wanted, I'm not going to ask you to do this, but remember how we used to talk about end behavior? As x approaches negative infinity, f of x approaches what? So think about that. As I'm going towards negative infinity, what does y, or f of x, get really close to?
0.
to 0. We used to say, oh, well, it's going down, so it's going towards negative infinity. This is going down, but it's not going to go past 0. So f of x approaches 0. All right, so then as x approaches positive infinity, f of x, or y, approaches what? So as I'm going this way, what am I approaching? Also 0, right? Again, I'm not going to ask you to go and do our set notation like that, but this is what horizontal asymptotes are going to tell me about. More important than what the horizontal asymptotes tell me is how we find them, though. So algebraically, I think this is actually easier. The math is cake. We have 3 rules I need you to memorize. Cool. Yeah. With horizontal asymptotes, I have 3 rules I need you to remember. Okay? For all 3 of them, I'm going to look at the highest degree. Yeah, the highest degree on both top and bottom. So I'm not worried about any other numbers, just the highest degree. Wait. Good? Okay. So rule number 1. Rule number 1. If the highest degree of the numerator is less than the highest degree of the denominator,
What do you mean by degrees?
hold on. And my horizontal asymptote is y equals 0. So the highest degree, so let's get an example. If I got, let's say, 3x squared minus 2x plus 1 over x minus 5. That's 5, not x. Okay? So the highest degree of the numerator is what? 2. 3x squared, right? So make sure you're in standard order or find whichever one's highest, right? Oh, yeah. It's made up. So 3x squared, so this is my highest one. All right, what's the highest on my denominator?
Just 1.
Just 1, right? Shoot. I wanted the opposite of this.
So does that mean that your
Stop.
horizontal
Stop. Stop, 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 stop,
is
stop.
1, isn't it?
Hold on.
Isn't it?
Hold on.
Yeah.
I just flipped it. I gave you an example for the next one. Hold on. Okay. Sorry, my bad. Okay. What's the highest exponent on my numerator? 1, right? There's a 2x to the first there that we don't see. What's the highest in my denominator? 3, right? My bad, guys. Then now you have to erase and catch up. So that's fine. Good. Yeah, I know. Get 10. Sorry. So if the highest degree of the numerator, 1, is less than the highest degree of the denominator, 3, my horizontal asymptote is at y equals 0. Not moved. It's right there at the x-axis, right? That's where my horizontal asymptote is. And that, I mean, that's literally rule 1. And that's the only horizontal asymptote. So if you look at your function and you go, all right, what's the highest exponent in the numerator? What's the highest exponent in the denominator? And you find out which one's bigger. Sorry, I'm using.
Forgive you.
Thank you. All right. Rule number 2.
How many rules are there?
3. I already said that. And I'm going to go a little shorthand. So if the highest degree of the numerator is equal right? If they're equal, and this is the kind of tough one, all right? You take the ratio of the coefficients. 3 equal 1. Huh? All right, looking at an example. Okay, let's actually use the one on my notes this time. Oh, I didn't.
Wow.
3x squared plus 2x plus 1. Okay, if I put that over 5x squared minus x plus 1. All right, so anytime I'm asking you for horizontal asymptotes, stop and look at your highest power. So the numerator, what's the highest exponent? 2. What's the highest exponent on the denominator? Also 2. So they're equal. So what I need to look at then is the ratio of the leading coefficients. So whatever number you were looking at, so the highest one is 3x squared in the numerator. The highest one in the denominator is 5x squared. What I want to take is the leading coefficients, 3 and 5, and make them a ratio. So the ratio here is I have a horizontal asymptote at y equals 3 over 5. That's just the number 3 over the number 5. So if they're equal, just take the coefficients. Sometimes there is no coefficient, meaning it's what? 1. So keep that in mind. If you can simplify these, do. If you've got, say, 20 over 5, simplify that. That would be y equals 4. Okay. Rule number 3 is very simple. What's the only thing that's less? I've had the numerator is less than the denominator. More. I've had it's equal to the denominator. So the only thing left, rule 3, or more, sorry, higher yeah, same thing, and I'm going short. So if the highest degree of the numerator is higher than the highest degree of the numerator, you're going to like this. There is no horizontal asymptote. So, for an example, two x squared plus 1 over x minus 3. So what's the highest degree of the numerator? 2. Highest degree of my denominator? 1. So the highest degree of the numerator is higher, so there is no horizontal asymptote in that equation. Second adjustment. Find all vertical and horizontal asymptotes. So I've got f of x equals -2 over x squared minus 5x plus 6. We just did this one. We did it for vertical asymptotes. So we'll go back. I want to make sure we're good there. Here's what I think, guys. The next question we'll have is find all vertical and horizontal asymptotes and find all intersects, x and y. So you got to do all these, 4 steps to find all 4. I would start with horizontal asymptotes because all I need to do, I don't even need to do math, right? I'm just going to write HA, okay, and then see what the highest power on my numerator is. What is it? The highest exponent? 1? 0. There's really, we don't see it, right? But this is -2 times x to the 0 power, right? Because there's no x there. It's just not even there. So if you don't have an x in either your numerator or your denominator, you know that it's 0. So 0, and then it doesn't even matter. As long as there's an x on the bottom, it's got to be big. So where is my horizontal asymptote? Which rule is this? Rule 1. So where is HA?
0.
Good. Y equals 0. That's all. You wouldn't need to show me that 2 is bigger than 0. That's really all the work to show me. So get your HAs out of the way real quick. Vertical asymptotes we already did. Okay? I factored this guy and found my zeros for it. So I had vertical asymptotes at x equals where? 2 and 3. Good. So that's it. That's it for that one. Okay, let's do the next one, B. What do we always start with? Horizontal. Good. I just think it's a lot easier. So horizontal asymptote. Good. So what's the highest power on my numerator? 1, x to the first, right? And how about the bottom? Also first. So which rule is this? Rule 2. Okay? Which means I need to get, how do I find my asymptote?
Ratio of coefficients.
Ratio of coefficients. So what's the ratio on my numerator?
Equal.
-1. Good. That's 5 minus x.
Unequal.
Right? 5 minus x. So -1 over what? 1. So my HA is at y equals -1. Good. Vertical asymptotes. So the only thing I care about with vertical, guys, is the denominator. Anything can happen up top, don't care about it. So I've got x plus 5. Can I factor that at all or anything? No, so let's just set that equal to 0. X equals -5. If you're not sure about that, take -5, plug it in. So -5 plus 5, 0. And on the bottom specifically, right, I'll have a 0 down here. And that means I'm undefined. So a vertical asymptote at x equals -5. Good. Last one. Start with HA, horizontal asymptote. Okay, so highest power in the numerator? 2. Highest in the denominator? 1. So what rule is this? Rule 3. How nice of me that I went in order, right? So when the numerator's highest power is larger than the denominator's, where's my horizontal asymptote? Nowhere. I don't have one. So you could write on here, no HA. That'd be fine. Or HA equals none. Or something like that. Is the X through it? Oh, like a round HA? It's not a weird smoothie bear.
No, I was talking about like a 0. I know there's going to be
Yeah, we don't win this solution. I'm just saying it's going to work. So, good. Vertical asymptotes. It's just like the one above it, right? I'll have x minus 9 equals 0. So x equals 9, and if I plug 9 in, 9 minus 9 is 0. So I have a vertical asymptote at x equals 9. Good. Yes. Find all asymptotes and intercepts, you guys. Find all asymptotes and intercepts. So intercepts, if I just threw, like x squared plus 10x plus 21, if I just threw that at you without the over x plus 3, what would you do in order to find x-intercept? You'd factor, what's an x-intercept the same as? A 0, right? Or a solution. A lot of times we'll just say solve for x. All you're going to do for x-intercepts, you guys, is that, right? But specifically, I want the zeros of the numerator. So I don't want you to find the whole thing. I'm not worried about the denominator. So for the denominator, that will give me my vertical asymptotes. But the numerator is where I get all my actual solutions, my x-intercepts, right? So then all that's left is y-intercepts. A y-intercept is where my function touches the y-axis, right? So what is my value for x when it touches the y-axis? Not specifically in this one, just in general. If my graph touches the y-axis, what is x? 0, right? That's where x equals 0. All you're going to do to find y-intercepts is take your original equation and plug in 0 for x. So, find all asymptotes and intercepts. I still recommend starting with one thing. What do you think it is? Horizontal asymptote, so HA. Alright, so highest exponent in the numerator, 2. How about the denominator? 1. So which rule do I want?
No.
Rule 3, right, which says what? Trent? Right, so no horizontal. Okay. Good. Let's do vertical asymptotes because it's actually pretty simple on this one, isn't it? Okay, I've got x plus 3 on the bottom, so I'll set that equal to 0. So I have a vertical asymptote at x equals negative 3. That's half of it done, guys. Right, so x intercepts zeros of the numerator. I only want the numerator. So let's factor the numerator. I got x squared plus 10x plus 21. Nothing I can pull out, is there? But 7 times 3 is 21, and 7 plus 3 is 10. So this breaks really easily into x plus 3, x plus 7. Good job, Colton. So I've got zeros of what?
-7.
Good. -7 and -3. Those are my x-intercepts. So just put a box around those. You can give me x equals. You can give me x-intercepts as points. So that would be x-intercepts. You label it and say -3, 0 and -7, 0. That's 0 for y. I'm also fine with this, as long as you make it clear that like this is different than this. So if you label your HA and VA, I'll be pretty good about seeing that that's your x-intercepts. Y-intercepts, last thing, right? I need to plug in 0, and this is the only thing where I need the whole equation, right? So plugging in 0, I get 0 squared plus 10 times 0, right? Plus 21 over 0 plus 3, which is 21 over 3. And somebody said it, that'll reduce to 7. So that's my y-intercept.
You just plug in 0 for everything.
You just plug in 0 for x. Find all the asymptotes and intercepts, same thing. So give me horizontal and vertical, and also x-intercepts and y-intercepts. I want you to do this on your own, but before you do that, watch. Trent just asked a question about the vertical asymptotes. So you'll go back and do HA. I want to do VA real quick, okay? So I've got x squared plus 1. That's not going to factor at all, right? If it was x squared minus 1, we could, but we won't have it. So x squared plus 1 equals 0. So x squared equals -1. So x equals the square root of -1, which is what? Just I, right? I am not, this actually does, this isn't just me. I am only interested in real answers. Okay? So for asymptotes, but also for x-intercepts and y-intercepts, if you get unreal answers, I don't want them. I don't want I. So you wouldn't write no real solution for this. You would just say no vertical asymptotes. Okay? Because there's none that are real. Make sense? If you factored 2x squared minus 3x minus 20, Christian, get off the floor. If you factored that down to x minus 8 and x plus 5, I get that you did 2 times -20, and you thought, oh, -40, 8 and 5, that's 3. If I factor this out, I'll get x squared minus 8x plus 5x minus 40, right?
Wait, no, wouldn't it still be -20?
No, it'd be x squared minus
Oh, yeah.
3x minus 40. Guys, is x squared minus 3x minus 40 the same as that? No. That's wrong. So, no, that's incorrect. No, that's what I'm trying to tell you, it's wrong. Alright, so the correct way to factor this, guys, AC method, I'm going to rewrite it, 2x squared minus 3x minus 20. So, I need to get -40, right? That's just 2 times -20. So what are my factors of -40 that add to -3? You were correct about this. +8 and -5, right? I can't just write that though. This pesky 2 is here. So 2x squared, and I'm going to write out, okay, minus 8x plus 5x minus 20. Then I'm going to work with each of these, okay? So what can I pull out of this first one? I can pull out a 2x, right?
Yes.
Or I could just, yeah, well, okay, let's pull out a 2x. Good, so 2x leaves me with what? X minus 4, good.
The 5.
You want to pull a 5 out of that?
Yeah.
So plus 5,
X minus 4.
x minus 4. Meaning my new factors are x minus 4 and 2x plus 5. Alright, set each of those equal to 0. X minus 4 equals 0, so x equals 4. And then 2x plus 5 equals 0. So x equals negative 2.5. Negative 5 over 2. Minus 5 from each side, and then divide by 2. So negative 5 divided by 2. So